So let's continue our work with addition and subtraction of polynomials, but this time we're going to look at functions. So I just want to remind you of our previous work on function notation. When you have something that looks like this, y equals f of x, the reminder is that f is the name of the function, x is the input variable. We also call that the domain value, so the input variable is x. And f of x is the range value, y, corresponding to the value x. So f of x is another way to say y, and it will be your output. So the output is f of x in this function. And the way that we read this notation like this is as f of x, which is the value of the function f at the given x. So that's just a little review on function notation, because now what we want to talk about here is how do we add if we're given two functions. For example, look at example number 1. You have the function f of x, which is x squared plus 5, and this function is a quadratic function. Let me help you with that name. Notice that the degree of the function is 2, and when we have a degree 2 function like this in one variable, this is called a quadratic function. And we're going to be doing some future work on quadratic equations, so it's good for you to start recognizing them. The graph of that function is a parabola, so it's going to look like this. Okay, so I'm just going to start getting you ready, kind of trained to look for these quadratics. So our first function f of x is this quadratic, f of x equals x squared plus 5. Our second function g of x is given by the equation g of x equals x cubed plus 3x squared minus 5x plus 6. So that is a degree 3 function, right? And we call those cubic. So this is a degree 3 function, and what we are now going to do in this problem is that given function f and function f being your quadratic, function g being the cubic, let's form a new function h that's going to be given by adding together f and g. Okay, so we're going to create a new function that's the sum or the addition of the two old functions f and g. It really is going to be just the way that you think it is. We're going to add f, so here's f, okay, and then to g of x. So right, because it says here h of x equals f of x, so notice how I replaced f of x with x squared plus 5, and then g of x is replaced by the cubic, just like that. And we're adding these together, and yes, if you think that we're going to add the like terms, you're absolutely correct. So h of x will be, now I'm going to put them in descending power, so x cubed, and then I've got these, so I get plus 4x squared minus 5x, and then I'm going to add the constants plus 11. And that is my new function h of x that was created by adding the two old functions together. Okay, in our next example, we once again have two functions f and g, and we're creating a third function h. This time we're going to subtract. So f of x is x squared plus 8. Do you recognize that as a quadratic function? Yep, it's a quadratic. X squared, right? Degree 2, and so its graph will be a parabola. I'm getting you used to that before we get to that chapter, okay? And then g of x is another cubic. And by the way, it just so happens that when we put together these class notes, we picked a quadratic and a cubic. We could have had different degrees for these functions, so it's just that we just happened to pick this. All right, and so now we're going to create that third function h by subtracting. So let's write that carefully here. Here's h of x, and we're going to subtract f first. So I'm going to replace that with f of x there, right? And then minus, and notice this parentheses is so critical, isn't it? So you want to make sure that that parentheses is there when you go to do these problems, or you will be wrong. You'll have all sorts of sign errors that you're going to wonder what happened. Remember our previous work? We have to change all these signs, don't we? We've got to change all these 4 signs to the opposite. So now I'm rewriting the x squared plus 8. The parentheses is not really doing anything, but now here I'm going to distribute that minus, or I'm going to change every single sign in that second parentheses to the opposite. So that's going to be minus x cubed minus 7x squared minus 2x plus 3. Notice all 4 signs were changed, and this is h, right? H of x. We want to make sure that we put them in descending powers of x. So that first term is negative x cubed. Then I'm going to add together the x squared. So that's going to give me a negative 6x squared. Then I have the negative 2x, and I'm going to add a plus 3, and that's 11. So this is my answer for my new function h, which was created by subtracting the two functions f minus g. In problem number 3, we have two functions again. This time f of x equals 6x minus 2 is, do you recognize that kind of equation? Do you recognize an equation that is y equals 6x minus 2? If you think that that might be a line, you're absolutely right. So this is linear, degree 1 this time, right? So f is linear this time. And then look at g of x. G of x is 9x squared plus 3x plus 8. What kind of equation is that? That's quadratic. That's our parabola. Okay, getting to know those parabolas before we have to work with them. So first we're going to evaluate f of 10. So as you know, that means that we're going to be using 10 as our x value in the function f. So I'm just rewriting, but where the x was, I put in the 10. And then I'm going to use my order of operations here, multiply 6 times 10 and get 60. And 60 minus 2 is 58. Okay, so that's your f of 10. Then I'm going to evaluate g of 13. So now I'm going to go to the g function, and where x is, I'm going to substitute in the 13. So we're here at our quadratic. And again, you know from our work in order of operations that we will square the 13 first. So 9 times 169. I'll go ahead and multiply 3 times 13 while I'm here, 39. Plus 8, and then 9 times 169. It's a good time to use my calculator for that. And so that's going to be 1521 plus 39 plus 8. And then adding all of those together, we get 1568. So now to evaluate f of 10 plus g of 13, we're going to go ahead and add together the 58 plus the 1568. So we add together the answers we got from here and here. Okay, sum up here. And that gives us a total 1626. 1626. And that's our final answer for problem A. Okay, let's go to the next one. Next problem, we need to evaluate f of 15 minus g of 7. I'm going to do those separately since it's a subtraction and it can be a little tricky. That minus sign, sometimes that gets in our way. So let's evaluate f of 15 first, and then g of 7, and then we will subtract the two. So f of 15, again, that's our x that's going to go into f. So 6 times 15 minus 2, which is 90 minus 2, or 88. So there's our f of 15. Now g of 7, that's our parabola, and this one's going to be a little bit more steps, isn't it? But I'm substituting in my 7 first. I'm going to do order of operations with the 7 squared, so that's 49. So 9 times 49 plus 21 here plus 8. And then here I get 9 times 49, which is 441, plus then I have here a 29, and so that looks like we've got 470. So g of 7 is 470, which I'm going to remind you what that means. That means that on the parabola we have an order pair, a point at 7 comma 470, right? That's what function notation. I'm just reminding you, just a little review. Okay, but we're supposed to be evaluating f of 15 minus g of 7. So that means 88 minus 470. And that means that our final answer is a negative 382. Again, notice we're getting a number. We're not getting a function with x's in it, but an actual final number. Okay, with C, however, look at C. Now they want us to evaluate f of x plus g of x. So here's where we're going to create a new function where we add the other two. And so I had to go back and look at my f of x. So that's 6x minus 2 for f of x, added to 9x squared plus 3x plus 8. And so we can just combine some like terms here and get 9x squared plus 9x plus 6 as our new function, f of x plus g of x, which sometimes you may see this notation. I want to introduce you, depending on where you're working. They will write f plus g like this and then put of x, and that means the same as f of x plus g of x. Okay, so if you see both of these notations mean the same thing. Okay, over here we've got f of x minus g of x. So we're going to make up a brand new function where we subtract the two original functions. So I've got the line 6x minus 2, subtract, and then I have the quadratic, right? I have to, for sure, be careful with that parentheses, because now we are going to change the three signs, aren't we? We're going to change those three signs. So here's another way. Here's another way to say the same notation. Okay, just so you can see it both ways. So now I've got here 6x minus 2 minus 9x squared minus 3x minus 8, changing all those signs. Then I have here minus a negative 9x squared, a positive 3x, and negative 10 for my new function. It's a degree function. It's a parabola. Okay, this difference function, we call that the difference function. It's still a parabola, but I'm going to tell you something. I'm going to tell you something about this parabola. See how this negative 9, this is the leading coefficient. When the leading coefficient in a parabola, in a quadratic like this function, is negative, then your parabola is going to, whoops, let's try that. Then your parabola will open downwards. It's going to go like this. And then look over here on the left. We had a f plus the sum here, f plus g of x was a positive 9x squared plus 9x plus c. This is also a parabola, but this coefficient is positive, so the parabola goes up. So this is just some ideas that I want you to start getting used to before we get to that chapter.